Okay, good morning.
Morning.
We will continue our discussion on C++ programming. I think I'll finish the concept of pointers this lecture, and the next lecture will we will focus on the concept of class, and then we'll wrap it up. So these two more lectures will finish the. We'll conclude C++ programming. Of course, I understand this is a very brief kind of overview, okay? C++ program itself could be a full semester course and with many details and elaborate issues. But we are going to just talk about what is enough for an FEM program. That's it. And many of the advanced topics are not discussed in this class. It is up to you to use this. And also, one thing I like to mention about programming is that usually there are multiple ways to do exactly the same thing. And some people choose to program it in a very concise way and a very advanced way. So in fewer lines, fewer statements, it accomplishes certain tasks. Other people may like to choose to write it more closer to plain English, so it's more readable. But when you do that, usually the program becomes longer. So again, conciseness and readability, they are usually conflicting with each other. For me, I tend to emphasize readability a little bit more than just using advanced techniques. The simple reason being that if I write a code that is more readable, years from now, when I look at it, I can understand it, much faster. And also, if I pass the code on to others, they can also understand it better, okay? All right, last time we talked about the arrays and character sequence. And in chapter 13, the concept of pointers, the concept of pointer is introduced. So chapter 13, pointers. The concept of pointer is pretty special to C and C++ programming. By the way, C and C++, they are very similar programming language. You can kind of understand that C++ is a augmentation of C language, okay? It's an enhancement of C language because plus is an increment operator, okay? You can also understand it that way. There's no equivalent concept of pointer in Fortran and some other languages. So what is a pointer? To understand the pointer, we need to understand that when computers work on numbers, they need to use the memory to perform manipulations. For example, if we assign the number of 10 to X, number of 20 to Y, what happens is the compiler will prepare memory spaces for these two variables. Memory spaces are accessed through its address. Okay? So when we declare X is equal to 10 and Y is equal to 20, then inside the computer, let's say this is X, this is Y. They, depending on how you declare it, they may not be in consecutive addresses. So, but one space is opened or reserved for X, variable X. One is reserved for variable Y. And this is 10, this is 20. So the value inside what is in the content inside the box here, which represent the memory space, is the value of that variable x, okay, like 10. Now, when computer try to access that, it needs to know where this x variable is stored. So there is something like a memory address. Let's say this is 1778, okay, and there are others. These may be 2020. These are the physical address of the memory space in the memory. Of course, different compilations, these may change depending on the architecture of the computer, and different computers, when you compile the code, this value will be exactly the same as far as these statements are issued. So this 10 and 20 will be exactly the same, but this memory space is computer dependent and also environment dependent. Okay? All right. At that point now you know there is 3 things associated with a variable. One is name, the variable name, which is x, or you can say that it is the label of the variable. One is its value, which is assigned 10 here. The other one is its address. Okay? All right. Now, when we use the label x, we mean its value. So it refers to what is inside the box. So whenever we write x, it represents the value. How can we access or print out its address? And C provide the operator for that. Okay? Okay, let me say here a variable. It has 3 elements. The name, or you can say it's the label of the variable. It also has value. It also has address. And for this particular case here, the name and the value are represented by the same thing, x here. This is the example when x is assigned the value of 10, which is also equal to the value of the variable is 10. Okay? Here is 10. The address for this particular case is 1778. Okay? So this is the label of the variable, this is value, this is address. And then C++ and also C provide an operator called the address of operator ampersand. Therefore, if you write ampersand and an x, it means this thing. It means the physical address of the memory, which is 1778. If you print that out, you will have the value of 1778. Okay? So that is the address of operator. Okay, up to this point, we are only talking about a normal variable, not a pointer. Now, because of the address, we may ask the question, is there something we can use to specifically for the manipulation of the address of a variable? The answer is yes. That's what pointers are for. Okay, so that introduce the concept of pointers. Okay, what is a pointer? Pointers are variables that are used to store the address of a variable, a normal variable. Okay, so pointers are especially declared for storing the address of a variable. Declaration of pointers has the following syntax. Okay, let me write here. Declaring pointers. Here an example. The syntax is this: type, and then a star, and then for good programming habit, we put a space here, and then we can say name. So this is the syntax of declaring a pointer. Okay, let's look at each individual element here. Type. What is the type? Type is the type of data. For example, character is one type, integer, float, double, long double, etc. Okay, these are the type. And this symbol, the star symbol, just signify that this declaration is to declare a pointer variable. Okay, and this is the name. The name is the label of the pointer, or the name of the pointer. Okay. This space here is optional. You can eliminate the space, but there is a reason that I advise you to put a space here all the time, because in this statement, that star is just for declaration, is signify that this is a pointer. Later, we are going to use star with a pointer to mean something else, which is called the dereferencing operator. Okay. All right. Let me first give you an example. If I have the following code block: integer, star, and space, and x. Okay. And then I have integer. Okay. I'm sorry. I tend to develop the habit that when I declare a pointer variable, I put a p in front of it, so that it can alert me to the fact that this is possibly a pointer variable, because we should use the pointer variable and the normal variable in different ways. Okay, so I'm going to put p x here, and then here x, another variable, normal variable, and initialize to the value of 2.5. Oh, it's an integer, so it's just 2. Okay, all right. Let's see what's happening here. I declare a pointer of px and a normal variable of integer type of x and initialize value to 2. And then, now, I want this pointer to point to x. How do I do that? Right now, these two are independent. They have no relation at all whatsoever. Okay? And if now I have a statement, I say pointer x is assigned the value of the address of x. That will establish the relationship. Okay? Let's look at this. The ampersand is an operator. It acts on x, so this element or this expression will give us the address of x, right? So once we have the address of x, because pointers are specially variables used to store address of something, and so that address of x is stored in the pointer variable px. After doing that, now let's see here. We have this label x. This value is 10. And now its address maybe, let me just make up a random number. Okay, depends on the actual computer. And this is address. Now, there are some other variables in the memory. And here I have a variable px. This is a pointer. And this now points to that. The pointer px itself is a variable. And because we do that, what do you think the content of the box here should be 1228, the address of this guy, which is 1228. Okay? And because px itself is a variable, it has its own address. So it may be 92322, something like that. Okay? So don't confuse the content of a pointer with its own address. And usually, actually, you cannot use a pointer to point to itself. Okay, that would be kind of ridiculous. The pointer will only point to other address of other variables. Okay, so this is a normal use of a pointer variable. Is here. All right. Now, let me introduce another operator. This is the address of operator. There is a almost like an inverse of the address of operator, which is called the dereference operator star. Okay? What is a dereference operator? Let's say we declare a pointer variable px. At the same time, we initialize its value to the address of x. Okay, and then x is assigned the value. Do this first. We declare integer x and assign its value to 10. Then we declare a pointer of integer type px. And then we assign its value to the address of x. That is perfectly legitimate if you do it like that. Because what it says is a declaration with an initialization. Okay? So a px is declared as a pointer of integer type. At the same time, the box inside is initialized to the address of x. So this is fine. Now, the reference operator, okay, let me put y here, declare another variable integer 1. Then star px means here when I write star px, that star becomes the dereference operator. It means the content of the variable that pointer points to. Okay? So it's the value of the variable that pointer points to. In this case, it will be 2. Or here it will be 10, okay? Because I use 10 here. Therefore, I can write y is assigned the value pointed to pointer px. Okay? Now, understand that this star means the reference value. It means a value pointed to by that. Because that points to, well, for this case, I need to erase that. If I want to reuse this has the value of 10. Okay? That pointer points to this x variable. It has a value of 10. Therefore, after the execution of this statement, what is the value of y here? This one? It will be 10. Okay? Therefore, this statement is fully equivalent to y is assigned the value of x. They are just 100% equivalent. Okay? All right. That also means okay. continue on this discussion, that also means x and star px, they are fully equivalent after you point px to x. Because star is a dereferencing operator. Okay, so the value pointed to x, of course, is here, which can be represented by x itself. Okay? All right. What about ampersand x? Ampersand x is equivalent to what?
Star px, or just px.
Star px or px?
Px.
Px. If you put star, then it becomes wrong, so it's px. Okay? All right. Because of that, here I use this. So I can say star px is assign the value of px I point px to x. So this statement says, now I point the pointer px to x. Okay? This is also fully equivalent to the value pointed to x is equal to x. Okay, you see the relationship between the two? Because this refers to the address of x. Pointer, once you assign the address of something to the pointer, that means that pointer points to that variable here. And this whole expression, if this is the case, is equal to what? Looking at the chart. The expression, remember, has a value which is, because it's a assignment sign, both left and right are the same. The whole expression itself carries a value which is either that or that. For that case, what is this? The value of this expression? 1228, right? Now these two are also equivalent. What is the expression of this statement, this assignment statement? 10. It refers to the value, so this is 10. Now you see how this relates to this picture. Okay? All right. Now, if I write this statement after I declared it, if I write px is equal to ampersand x, is this okay? What does it mean?
You're assigning an address to a value.
Which means
It's not allowed.
is absurd, right? The right-hand side refers to its address. The left-hand side refers to its value, and you can see clearly they are not equal. Therefore, this thing as a statement is just an illegal expression. Okay? Now, be careful here. Let's look at this. Here, this part is very similar to that, right? But this is allowed. This is not allowed. So therefore, there is a difference between declaration and an executable statement. Why? Because the star here is an indicator that something is declaring something to be a pointer. It's not a dereference operator here. This is not dereference, okay? Therefore, I would say this is a declaration. And this is dereferencing. Okay? These two means different things. They just happen to use the same symbol star. That is why I advise you, when you declare something, put a space after the star so you can recognize, okay, I'm not dereferencing anything, I just declare a pointer. And in later statements, you eliminate the star and then you view this as one thing. It means this referring to its value, pointed to by that pointer, okay? And here is dereferencing, here is address of. Now once you understand both, you can see clearly this statement just make no sense at all. Actually, you will see an error, okay, when you try to do things like that. Okay, I think the most useful thing to understand pointer is by the picture here. X is the label of the variable. Here is the address. Here is value. And draw another box, pointer. It points to that. And then once it points to that, this address will become the content of that pointer variable, and it has its own address. Something like that. This picture is the best to understand pointers. Okay? With that, now, here I will put a dot here and draw outside. This, you can use X to represent it. You can use star PX to represent it. Here, you can use PX to represent it. You can also use ampersand X to represent it. Because ampersand X means the address of. Okay? So, come aside here, come aside. Well, I like to emphasize that when you declare pointer, because the type here, the pointer of one type of variable one type of data can only point to a normal variable of the same data type. You can, here, this is an integer type, so that pointer is of integer type. If this is double, this needs to be double. You cannot use an integer type of pointer to point to a double. Okay, that is not allowed. And here, but the same pointer, after you declared it, at some point in your program execution, you want to point this pointer to one variable and do something. And later, if you change your mind or you want to reuse the pointer, you can point the pointer to a different variable of the same type and keep operating, keep your execution. This is perfectly normal. And in fact, sometimes it's advantageous to do that because you can reuse a pointer to achieve a lot of things without declaring too many or a lot of pointers. Okay? All right, because of that, as you can see, now we can see for a value, you have at least two ways to refer to it. For address, at least two ways. Then you can do really neat things with pointers. Okay? Let's see if there are some interesting examples that we can use. Okay, one more syntax. Now, pointer declaration. When you declare pointers, you can use one data type and then put as many pointer variables as needed on the same statement. But each of these need to have a star space, star PZ, like that. This is equivalent to 3 independent statement, integer space star space px, semicolon, and then integer star space space star space py. Oh, this one is py. And then another statement declaring pz as a integer type of pointer. But if you write this, what would you get? Px is what?
Pointer.
A
PX is-
pointer of integer type. What about py?
They're not.
They're just integers.
Py is just a normal variable, py, and pz is another normal variable. Okay? Now, let's say, now I have a code block like this. Let me use double, okay? Because in most calculations, a double will be used more. X, Y, Z, and then double star P, T. My X is equal to 2.5. Okay, just to practice the use of pointers. Okay, I have the following code block. Oh, here, should have a semicolon here. Okay, I declare this x, y, z double type and then a pointer. And after here, after that statement, execution of the statement, what would you see on the screen? Here?
2.5.
So you will see 2.5 on screen. Oh, here I can have Q out X, Y, Z. Okay. What about here?
Also 2.5.
2.5. What about here? What will you see on the screen? Well, this is not a very good way to do it. Let me say this one. X, Y, Z, okay? All right, here, what will I see on screen? 2.5? What about here?
2.5.
What about here?
8.2.
8.2. Okay, now I have one more. And then now I need to draw a picture. This is my x, this is my y, this is my z, this is 1.2, 1.6, 1.110. Okay, what would I see here? After the execution of that statement. 110. Very good. Okay, now if you understand that, I think you have a good handle on what the pointer is. Let's see here. First, of course, this is a normal assignment statement. The output x, of course, is 2.5, right? Now, here it says the pointer pt points to x. Actually, I need to draw another picture. This is pt. It has maybe 908, something like that. After this statement, what happened is this pointer now points to this guy, points to x. Right? And then what should I put in the box here after that statement? The box here will have the value of 102, which is this one. Okay? So after that. And then this output is value, this says output the value of the pointer pointed to by pt, of the value pointed to by pt. pt points to that. Okay? This is 2.5 here, so the output 2.5. And this statement says, now I will assign the value pointed to by pt to y. So after this statement, this is like that. And at that point, that pointer still points to that. Okay? But here is just a dereference operator. It means it refers to this value. So this value is taken and put it here. And then that statement says, now, what do I do?
Change the address.
I assign the value of the address of z to pt, the pointer. Then this arrow is broken, is removed. It no longer points to this. Instead, this time it points to that. Okay, after that statement. And then what changed correspondingly? The box content will change to
110.
110. Okay, so after that statement, that's what the picture will look like. And then next, I said the value pointed to by pt, it becomes what? 8.2. Therefore now this becomes 8.2. Okay? And at that point, you output all these three things. It will be like that. It makes sense now. Okay? This is outputting x, this is outputting y, this is outputting z, and this is outputting the address of z. All right. Therefore, with this picture and the understanding of pointer, I think you should have no problem using pointers. Okay? In fact, for me, this kind of picture helps tremendously. Okay? I will advise you to also do that when you program something. All right, another important issue or use of pointer is the relationship between pointers and arrays. Okay. Remember last lecture, we introduced the concept of arrays. It just happened that in C or C++, pointers and arrays are almost can be used interchangeably. The reason is that when you declare an array, the array name is a pointer that points to the first element of the array. Let's say we have integer array 1 of size 20 and all initialized to 0, for example. And then I declare a pointer what happened is this. Okay, you should understand that the name array 1 is actually a pointer. And it points to the first element of the array. To access individual element, you use this syntax. The array name with the dimension, or with the index, inside a square bracket. So the first one is array. The label for the first element here is array square 0 square. Okay? And the second is array square 1 square, like this. And array 1 itself is a pointer that points to the first element. Therefore, because of that, I can say pt1 equals array 1. Okay, I'm sorry. Here, because the name is array 1, there's 1 here. Okay? That should be array 1 square 0, array 1 square 1, up to array 1 square 19. Remember, there's an offset of 1, because it starts from 0, not 1. Okay? Now, because of that, what happened? I declare an integer pointer of pt1. It has its own memory address and content. And that statement says, I'm going to point this array, point this pointer to the first element here. Therefore, this is perfectly valid because array 1 itself will have the address of this element. This says put the address of this element into the box here. That means that pointer points to that. And now you can see, once you do that, a pointer to an array and the array name itself, they are just kind of equivalent. And they are both pointers. Okay? And there is something called the pointer arithmetics. I would like to skip that because this is more like advanced issue. What happened is you declare pt1 as the. If you declare pt1 as a pointer, it points to that. What does plus pt1 mean? It just means move the pointer to the next element, which will point the pointer here. Okay? If pointer 1 is equal to the address of array 1, 0, so that will point the pointer here. And next you say plus pt1. the pointer will then point to the next memory location. Okay, that's that. What do you mean? You can also say PT1 is equal to PT1 plus 1. And these two are fully equivalent. But here, what happened is, it's not like the address is changed by value of 1. No. The address is changed by one location. So that one means the next. If currently your pointer here, this statement will say now point to next location. That's what it means. And the value here will have the address of this location. Okay. If this is 102 and this becomes 106, for example, then initially if PT1 points to that, after that statement, PT1 will have the value of 106. As you can see, 106 is not equal to 102 plus 1. Is equal to 102 plus the length of one memory space. Okay? That is because, okay, because pointers itself, any numerical value itself may not be meaningful at all, but the address values will be meaningful. And this is actually similar to the address in the United States. Because when I first came to this country, I realized that the household numbers, they are usually not incremented consecutively. It's usually by a difference of 4 or something, right? So you have 3002, the next house is 30, usually 3006, not 3003. Very similar to the pointers here. So if you say my house is 3002, my next door address is not 3003, it's 3006 because the increment is by 4. There is also, you can also declare constant pointer. Constant pointer sometimes is useful because you want to refer to the value pointed to by the pointer, but you don't want to change the pointer itself, so you don't want to modify it. So the declaration will be like this. If you say, I have an integer y which is equal to 10, and I also have an integer x, declare that. And then now I declare a constant integer pointer, let me say p, and I initialize this value to the address of y. This is perfectly okay. What happened is this. Okay, now I have x and I have y, I have p here, and that says I point p to y, I initialize this value to be 10, okay. Alright, let's say now I have x equal to star p. What happened if I do that? What is 10? X has the value of 10 here. And now, if I just accidentally write that, what will happen?
Why would take the value of x?
So this says the value pointed to p is the value of x. So you actually attempt to point this pointer to x. And if this is the case, at that point you will encounter an error message. Why? Because of that keyword here. If there is no constant keyword, that is perfectly okay. You are allowed to point pointer to wherever you want, depending on your need. But you put a constant here, that means the position you point to cannot be altered. It will always point to that. So it's a constant pointer. It points to the same address all the time during the execution of the program. Okay? So this is not allowed. And similarly, of course, this is not allowed. Because these two statements are completely equivalent of each other. You can see that, right? And that's also not allowed. Because what you intend to do here is now point P to X. And again, this will not be allowed because of that constant keyword here. And you can also see X star ampersand X. These two things are the same. Therefore, the reference operator and the address of operator, they are the inverse operation of each other. Because if you have a pointer that this thing refers to the pointer, right? And okay, in this case, I should put Y here. This is exactly P. Okay? Because you assign P to point to that. And the reference P, of course, gives you the value it points to, which is 10 itself. Therefore, these two things are completely equivalent. Okay, next, let's talk about pointers and character sequence or strings. Let's say I declare a statement. Okay, this is about pointers and strings or string literals. Okay, let's say I declare a constant pointer of character type full, which is equal to a string hello. Alright, what happened is this. For this declaration statement, this is a string. Strings are nothing but null character terminated sequence of character type. Okay? Therefore, in memory, okay, we have 1, 2, 3, 4, 5 characters there. But for string, always one extra is added, which is the null character at the end. So I have here 1, 2, 3, 4, 5, 6. So 6 memory spaces are needed. The first one will have the value of H. The second is E. Oh, a character is in a single quote, not double, okay? So this is H, this is E, and this is L, this is L, and this is O. And don't forget that it's 0. Backwards slash 0. This is the null terminated character. Alright, 1702, 1703, 1704, 1705, 1706, 1707. Let's say these are the memory address. And what happened is this declaration open a pointer named full, and it points to the first element of the array sequence. Therefore, what should I put in this box here? 702, okay? 1702. because it points to that. The address of this character is here. Okay? Alright, now if I want to refer to this element, how can I do that? The question is that I want to refer to this guy. This is treated as an array of characters. If it is array, what is the array name? This is the array name, right? Pointer point to the first element is array name. Therefore, I can refer that to FOO. I need an index.
Square bracket.
Square. How much?
4. This is characters, so it's 4.
4. Because this is 0, 1, 2, 3, 4. Okay? So this thing will give me that. I have another way to do it. If I take a pointer and add 4 units to it, it means what? It means move the pointer 4 times consecutively. Okay, 1, 2, 3, 4. This thing actually points where? 4 plus 4 actually points to the 4th element down the row. Okay? Therefore, now this points to that. This actually will give me the value of what? If I write that, what is the value of this expression?
Oh, the address of this is 1706.
1706 is this guy. Now, if I do that,
Yeah.
what do I have?
Now you have
What do I have?
No.
This guy. So this gives me that. 4 plus 4 give me 1706. Okay. This is a very good example to illustrate the concept. Of operator, the reference operator, and the pointer arithmetics. Okay? Okay, there's some. You can do these one more layer. You can. A C++ allows you to declare pointers to pointers. Okay. How does that work? Well, let's say I have a character declaration A character pointer B, and then a character double pointer C. Now I initialize A to character Z. I point B to A, and then I point C to B. Okay, the following picture I explain what happens. This is A, let's say this is 1024, and then I have another pointer B, and then I have pointer C. Okay, after that, let's say this is 2016, okay? 90012. Okay, I have these.